Hi, my name is Jeremy Howell, and this is my MAE ECE 535 experimental demonstration on the principles of three-phase brushless DC motor control. And this project will demonstrate a few of the high-level principles that goes into the control of a three-phase brushless DC motor, that being the speed and direction. Now, a typical three-phase brushless DC controller has a lot of very complicated design techniques in it. Oftentimes there are microcontrollers that will receive a user's input and based on that decide where the motor needs to go, how fast it needs to get there. A typical brushless DC motor is controlled, the speed and torque is controlled via PWM, the duty cycle of a pulse width modulated signal, and the position is controlled via proper commutation based on the direction you want to go of the motor windings, as well as position feedback, which comes from Hall sensors placed at a particular spacing around the back end of the motor towards the wires that senses the changes of magnetic field within the motor. You could have current sensing based on the back EMF, but in my experimental demonstration I don't have any position feedback. I'll just simply be running through a known set of states that would drive theoretically a brushless DC motor in a clockwise or counterclockwise direction. So my design consisted of a variable frequency 555 timer circuit that has a voltage divider and a charging and discharging capacitor. The back half of the voltage divider is a potentiometer that goes from near 0 to near 100 kiloohms, and that across the entire resistance of the potentiometer adjusts the frequency of the square wave, the oscillating square wave. The duty cycle stays at near 50%, a little over 50%, and as the frequency changes it causes the sequential logic circuits that I've developed to clock in data faster or slower, which then causes the output to change faster or slower. The clockwise and counterclockwise circuits are created using JK flip-flops that are combined in a master-slave sequential order that through feedback creates a set of known states on their output that are then connected through a set of 6 OR gates to 6 LEDs, 3 green and 3 red, that represent high side and low side FETs that would control the motor windings. So the direction of my demonstration is controlled via switches, and as I've said before, the speed is controlled via potentiometer. So I'll go ahead and show you the demonstration. Okay, as you can see, there's my breadboard, both breadboards actually. I have it hooked up to a 5-volt DC power supply. The small circuits in the middle, here and here, this is the 555 timer circuit connected up to the potentiometer, and then you have clockwise motion, counterclockwise motion, which is controlled via this switch, which controls the oscillator output, so which set of logic it goes to, and that switch up there, which is the power switch, which just delivers 5 volts to the clockwise or counterclockwise circuit. Over here on this jumper breadboard, we have the OR gates, and we have a series of LEDs, 3 green and 3 red. As you can see, it's cycling through now. I'll show you that in a moment. So yeah, the mess of jumper wires, they're everywhere, but the long green ones on the top are your outputs, and the jumpers in the middle just connect out your various outputs. So if you will, I'll show you the LED outputs. I'm going to flip the switch on the light so that you will be able to see the LEDs. Alright, as you can see, they are running through the counterclockwise sequence now. And as I adjust the potentiometer left and right, it slows down or speeds up the LEDs. So a little bit about that. What you have here is the green high side LED and the red low side FETs. And all that's doing is simulating the way that you would turn the FETs on and off to commutate the motor. So turn high side green on, low side red, and then you should just step through in that order. And then the control itself is via this potentiometer. So as I turn it to the right, it slows it down. As I turn it to the left, they speed up. Okay, now flip these switches, flip and flip, and the motor starts going in the opposite direction. Slows down, speeds up. Now let me turn the light on so I can show you exactly what I'm doing. Alright, so there's the LEDs, they're blinking. This potentiometer is what I've been turning clockwise to slow them down, and counterclockwise to speed them up. And then all you do is flip the clock switch and this back over. And now they're running directions. Flip that, and we'll get them changed up again. So that's it. I hope this breadboard demonstration has been helpful. I enjoyed making it very much. It was nice to get back into some calculations and hands-on work. So thank you very much.